Okay, so in this lecture, I'm going to talk about TCP, and the UDP. So the UDP is, as you can see, if you look at the UDP header, right? It's very simple. It has only like 4 fields, and especially the most important field are source port number and destination port number, right? Those are the most important field in the UDP header. And compared to the TCP, the UDP, so the UDP is called connectionless, right? The connectionless transport protocol, while as the TCP is called what? Connection oriented, right? So if you look at this, you have Ethernet header and IP header, and inside, instead of a TCP header, the UDP header is used, right? And there's a couple of applications that the UDP, where the UDP is very useful, right? For example, like the voice, like multimedia applications, because some missing data can be tolerated, right? So, for example, let's see, let's just summarize a couple of things for the TCP, right? For the TCP. We have what? A sequence number, and we have what? We have ACK number, right? And then the source port number and the destination port number, right? And then there are 3 flags that I want you to memorize. Although we have a 6th flag, the 3 most important flag is what? 3 important flag is SYN and ACK and the FIN, right? Although we have a 3 more. Okay, and especially since the TCP has this sequence number and ACK number, right? Because of this, the TCP is called a reliable service, right? It's a reliable protocol because there's the sender sends the let's say packet, right? And then the recipient has to send back to acknowledgement for this the packet it received, right? So in that way, it's reliable. If the sender sends it, and then if that packet is lost somewhere, right? Then this ACK packet is not going to be sent from the receiver. So the sender knows, okay, if the time expires, right? And then the sender knows that there's something wrong with the packet he sent previously. So it's going to retransmit the packets, right? So this is like a retransmission. So in that sense, this sequence number and acknowledgement, play a very important role, right? But however, if you look at the UDP, it only has, it has 4 fields, but the 2 most important fields are what? Source port number, and then what? Destination port number, right? So this is like TCP versus a UDP. And if you look at the packet structure, so we have, let's say we have what? We have IP header, right? And then previously, in case of TCP, we have, depends on the application, we can have either TCP or the UDP. And this one is like, and then the data. And then this depends on the applications, right? For the TCP, application is like a mail, right? So let's look at the applications. App, like a mail, for example, because it has to be reliable, right? If the data is missing, you will have a problem. So the mail is good. The mail use a TCP, right? And HTTP, right? Your web. This is a protocol for the web, and of course the web use a TCP because it has to be reliable. However, let's look at the applications where the UDP is very useful. One of the applications is, for example, voice, right? The voice over IP. Some of the data can be lost, right? Of course, the quality is not going to be really, you may suffer, right? If some of the data is lost, then you may hear some noise, right? But still you can hear, right? Still you can understand the voice, right, from other party, right? And then like multimedia applications, right? Multimedia applications, right? For example, yes, if you lose some of the data, the quality of the video is not like it's not really 100%, right? But still, I mean, you'll see some jitters, right? But still, it's okay, right? But there's a pro and cons, right? What is a pro? For the TCP, right? The pro is obviously it's reliable, right? And however, what is a con? It's heavy, right? And it's, for example, you have to send the you have to send the packets, and then you have to send another packet. You have to another data, right? You have to wait for the ACK, right? And then you have to send the packet, and you have to wait for the acknowledgement. So in that sense, it's performance-wise, there is some overhead. So heavy means there is a performance overhead, right? So that means basically it's kind of slow. Because of you have to, for every data you have you send, you have to wait for the ACK, right? Data send, you have to wait for the ACK. Data send, you have to wait for the acknowledgement. Okay, so it's kind of heavy, right? That means that there's the TCP suffers from a performance overhead, and that means basically it's kind of slow. However, the UDP, right? UDP is pro. It's not reliable, right? So for example, if you look at the lecture slide, since there's no handshaking, there's no three-way handshaking, it's unreliable delivery, and no error checking, and no flow control, no congestion control, and no order delivery. Okay. However, there is a good thing about the UDP is they're not reliable and no error checkings and all that, right? All the problems. However, so that's a con. Okay? That's a con, right? That's a disadvantage. And what is a pro? The pro is what? It's almost, there's almost no performance overhead. Since you send the data, right? You send the data. Let's say this is the sender, right? And then there's a receiver. So sender basically sends the packets, right? It sends a UDP packet, for example, the IP, and then you have a UDP header and then data, right? So you send this data to the receiver. You can keep sending all this data, right? Without worrying about getting the acknowledgement. So send the data and send the data and send the data and send the data, right? I know that some data can be lost during the transit, right? But some of the applications, they don't really care, right? So you just keep sending the data, right? And so pro is almost no overhead. Basically, that means it's fast. Okay, so that's the pro and cons of TCP and UDP, right? So basically, this really shows that TCP versus UDP. Okay, so that's about it. Okay, so I'd like to end my lecture here.